Hi guys, here we are with the checkpoint 2 review. And let's start with question number 1. The apparent absolute function is f of x equals, remember it's the simplest form, absolute value of x, which is shown below. Find the following characteristics. The vertex is right here, and that's at the point 0, 0. The domain, remember this arrow is going up and to the left, up and to the right. And for domain, this arrow's left, arrow right. That can only mean one thing, all real numbers. Range. Range is up and down. You see the arrows here. It's going up, and it's going up. It means they're both going up, so there has to be such thing as a lower value, and that's located at the vertex, the 0. It's part of the graph, so bracket towards positive infinity. The axis of symmetry here, we can see it clearly, is right on the y-axis. Now guess what? You probably won't see y-axis. You might see it as x is equal to 0. Remember, every time x is equal to a number, it's a vertical line. Got it? Last but not least, do we have a maximum or a minimum? Well, let's go ahead and look at the vertex. Is that the lowest or the highest point? Obviously, it's the lowest, so it's a minimum. Now we hear question 2. If we transform the parent function f of x to create g of x equals to negative 2, absolute value of x minus 4 plus 2, graph g of x and explain the transformation. So let's start by identifying what each variable is. This is my a. This is my h. Remember, that's the opposite child. And this is my k. Right? Our a. This is our a, h, and k. Our a, remember, tells us two things. The simple fact that it's negative, right? It's negative. That tells us it's reflected over the x-axis. Basically, opens where? Down. Right? The other part, we look at the number itself, and we know that the absolute value of negative 2 is equal to 2. Now remember, if it's bigger than 1, it's a vertical stretch by a factor of, well, the absolute value of negative 2 was 2, so that's exactly what we're going to put, factor of 2. Our h was 4, negative 4, so guess what? Negative 4 we think left, but it actually goes to the right. And then 2. 2 where? 2 up. So when it comes time to graphing, we're going to start with going right, left, up, or down. We go 4 to the right, and then 2 up. This is now my vertex. Now, we do acknowledge that it opens what? Down, so everybody should kind of have an imagination of how it's going to go down. I did teach you, though, one easy way of graphing this is looking at our A. What was our A? Negative 2. That is our slope. So we're going to start at the vertex, and then we're going to go down to 1 to the right. Why? Remember, our slope is negative 2 over 1. Down to 1 to the right. I'm going to do the same thing on the opposite direction. down 2, 1 to the left, down 2, 1 to the left, and I have my V shape. Beautiful. Now I can answer this question. What is the value of g of 3? What's that, 3? That's our x value. So they're giving us our x is 3. What is our y? So g of 3 equals, here x is 3. What is the y value there? 0. Boom. So our y value is 0. Now, hopefully you remember how to do the transformations. If you do, you should make some connections with these. We basically have to connect the graphs. Now, the one we were most familiar with was our form with the absolute. But we also have to keep in mind that it could be written in function notation. So let's look at this first one. It moved 1, 2, 3, 4 to the right, 1, 2, 3 down. This point is negative 4. Positive 4, negative 3. So I usually like to see if we can see which one it is. Oh, 4 to the right would mean negative 4. Both of these have negative 4. And then 3 down. They both have 3 down. The difference is, well, the slope part. This has a slope of 1. This has a slope of 2. Let's check at this graph. What does it have? I'm going up 1, right 1. So 1, 1. That would be A. So let's look for a point that has the same vertex. It's this one. So I'm guessing that should be this one right here. Let's see, let's check the slope. Up 2, 1 to the right. Yes, that is C. Now let's look at this one. Our vertex is at 0, 0. So that means there's no H and no K. And for the remaining ones, the only one that doesn't have an H and a K is this one right here. Now there's a slope of negative 1. Let's check it out. 1 down, 1 right. Yes. B. Last but not least, this one must be D. And just for the heck, let's check it out. It went 5 to the left, 2 down, and it's reflected. It's going down. Boom, that's what the negative tells us. Awesome. Now, question number 5. How to solve absolute functions. Hopefully y'all remember, right? First, we have to isolate the absolute. So we do plus 5. 16 is equal to the absolute value of 2x minus 4. Yes? Now, after this, we create two cases. 2x minus 4 is equal to 16, which is everything the same except the absolute. And the other one, the 16 turns into a negative 16. Then we solve the process, right? Plus 4, 20 equals to 2x divided by 2. X is equal to what? 10. Next one, plus 4, negative 16 plus 4 is negative 12, divided by 2, x is equal to negative 6. And those are our solutions. You could even say the set of negative 6 and 10. Next two questions If you notice, ooh, they're inequalities. So remember, we have the inequalities are awesome. We have to determine if it's an and or an or. Let's look at question number 7. That one's simple because it is isolated already. So we see the absolute value of 2x minus 1 is less than 9. That tells us that it's a and. Now this one, question 6, we can't tell yet until we solve for the absolute. So let's go and do that. Let's get rid of that 2 first. Plus 2. 20 equals to 5. Absolute value of 2x minus 4. It's not by itself yet. We got to get rid of that 5 by division. 2x minus 4 is greater than 4. The absolute value is by itself. Yes, now we can confirm this one is an OR. Every time the absolute value is greater, it's an OR. Less than, it's an AND. So let's go ahead and solve this one first. 2 cases. 2x minus 4 is greater than 4. Second case, you switch the inequality symbol and the sign. And now we solve. We got to get rid of the subtraction of 4. Oh. By doing the opposite. Then get rid of the multiplication by division. We do the same thing over here. Negative 4 plus 4 is 0. Then divided by 2. X is less than 0. So this was an OR. So here's 0. Here's 4. We have open circles. And ORs go opposite directions. For the AND, okay, let's go and get it done. We could do the same thing, put in 2 cases, or we could go 3-way. Let's do it. Right? You write the same thing that you had, and then -9, boom, on the other side. Let's solve for x. So we got to get rid of that additional 1. Whatever you do to one side, you do to the others. 9 plus 1 is 10. -9 plus 1 is -8. Divide by 2. Do we search the signs? Nope. Because we're dividing by a positive number. So now we have it. Let's say -4 is here. It's not equal to, so it's an open circle. 5, open circle, in between. Let's move on to the back. Boom. Now, question 8. This, I have not taught you this before, so yeah, surprise, it is what it is. Okay, let's talk about what I have taught you before. All right. If there's a number outside being multiplied, that is our A. Right? So it hasn't shifted left or right. It hasn't gone up or down. There's no H or K here. So our vertex stays here. Right? The negative tells us it's reflected over the X axis. Meaning it opens what? Opens down. Yeah. All right, and we see it's a vertical stretch. Why? Because the absolute value of -4 is 4. So it's bigger than 1. And we say by a factor of 4. So we would go 4 down, 1 to the right. And opposite direction. we'd have a graph like this. Now, how about this? This -4 is next to the x. It's being multiplied. We are used to seeing f of x minus 4 or plus 4, but we never talked about whenever there's a number inside being multiplied times x. Okay? Now, I'll share some knowledge with you right now. We're going to talk about this more later on, but what I do want you to know is that everything inside the absolute or everything inside the parentheses works opposite. Why am I saying this? We see how it's a negative? At negative, tells us is reflected over the y-axis. Okay? And then we think it should open what? Down, but since it's on the since it's on the inside, it doesn't open down. It opens what? Up. So in this situation, here's our 0, 0. Our vertex, instead of going down for 1 to the right, we're going to go the opposite direction of down, which is up 1 to the right, up 4, 1 to the left. Voila. Yes. That's what's up. Okay. Next question. At Vista, melons sells for $3 each and apples for 50 cents each. Joe has $10 to spend and must buy at least 11 fruits. Circle all the systems that are correct. So, let's talk about this. Money. All this is talking about money. So guess what? Melons sell for $3 each. So 3M. Apples, 0.5A. And Joe has $10 to spend. So that's the most he has, right? So he can't spend more than 10 because he don't have. So we're going to say less than or equal to $10. Now the other equation, the other part as well says you have to buy at least 11 fruits. What fruits are we talking about? Melons plus apple has to be greater than or equal to 11. Which answer is that? Now, please read the instructions carefully. Circle all systems that are correct. So I kind of wanted to trick you on this one. Pretty sure that most of you will be like, ooh, 3M plus 5A. A works because they're identical. B doesn't work because M of A is less than, it should be greater than. But guess what? C also works. How's that, Mr. Bendu? Well, guess what? You see how A is by itself here? What if I would solve for A here? What would I do? I would get rid of the M. What would I do? Minus M, minus M. A is greater than or equal to negative M plus 11. There you go. Just to show you that, hey, sometimes we got to be a little bit careful and examine the answer choices a little bit better. Question 10. Same idea, right? Bobby went to Taqueria Wednesday, Thursday, and Friday. On Wednesday, he bought 1 agua fresca, 2 tacos, and 3 churros for $16. So let's call this. There's ATC. I'm guessing this is A. This is T. And this is C. Let's look at that question. 1A, 2T, 3C. This part has it. And it's equal to 16. So that one works. This one works. This one works. Okay, we can't eliminate any answers yet. Thursday, he bought 2 aguas frescas, 2 tacos, and 1 churro for $17.50. So that would be 2A, 2T, and 1C. 2A, 2T, 1C equal to $17.50. 2A, 2C, 2T, and C equal to 1750. So that works too. 2A minus 2T. Nope. Now between A and B, last but not least, Friday he bought 1 agua fresca and 2 tacos. Ooh, no churros this time. Oh, A is wrong because it has churros. If you have a variable there, you're saying that you at least bought 1 churro. But we didn't buy any churros. Answer is B. So sketch a system of linear inequalities. Boom. We're going to go ahead and make this one. Okay. And we're going to go ahead and make this one the blue one. Here we go. Yellow one. This is my slope. This is my y-intercept. My B. Right? So it starts at 1. And then it's going to go down 4. 1, 2, 3, 4. 3 to the right. Down 4. 3 to the right. Opposite direction. Up 4. 3 to the left. Now, it should be a dashed line, right? And what side will we shade? It says y is greater or above the rest. So, find your y-intercept. Above would go this direction. That's the side we're going to shade. Now, the blue one. This is our M. This is our B. -3. Go up 1, 4 to the right. Backwards, down 1, 4 to the left. And it's equal to, so that means a solid line. This is y is less than, so we have a solid line. I'm going to shade below. Voila. So guess what? This is our solution area. But on your test, I don't know if they're going to have that like this, or if they're just going to have the part that's the solution shaded. So be aware of that. Question number 12. Which points would be a solution to the system? Okay. We don't have a graph or to graph them. All right. So there's a couple things we could do. We could plug in, and that's exactly what I'm going to do. I'm going to start with A. This is my X. This is my what? Y. And I'm going to start plugging into this one because that's easier. So -3 plus 5 is less than 7. Negative. It's a +3. 3 plus 5 is 8. Is 8 less than 7? No. Let's try the next point. Negative, our x is 3, plus -5 is less than 7. -3, that would be -3. Plus -5 is -5. -3 minus 5 is -8. Is -8 less than 7? Of course. Every negative number is going to be bigger than the other one. So, that's checked. But I can't say it's a solution if it doesn't work for the other one. So let's plug it into the other one. And so it would be 3 times 3 minus our y is -5. Less than 14. 3 times 3, 9. Negative turns into a positive. Boom. 9 plus 5 is 14. Is 14 less than 14? No, it's equal to sucks. So guess what? Didn't work for that one. Now we're gonna go to C. I'm still gonna plug into that first one because I think that one's easier. So I'm gonna say negative, -2. You don't know what I'm talking about? I'm talking about this one, right? Cut. Replace the y with a 7. -2, negative, it's a +2. 2 plus 7. 2 plus 7 is what? 9. Is 9 less than 9? Oh, 9. What? That's supposed to be a 7. Is 9 less than 7? No. So by default, the answer should be D. But let's check our work. Let's make sure that we're doing things right. So x, y here. I'm going to plug it in. -2 plus -7 is less than 7. Negative is a +2. 2 minus 7 is -5. -5 is less than 7. Check. So this one worked. Just plug it into the top one. I'll put it here. I'm going to replace the x with a -2. The negative with a -7. Less than 14. 3 times -2 is -6. Negative is a +7. -6 plus 7 is 1. Less than 14. Yes. Last but not least, question 13. Hopefully you remember how to tell if things are solutions, right? If it's in the shaded region, it's a solution. So let's start with the ones we know right off the back. D is in the solution part. That is a solution. D was a solution. Now, G is on the outside, not a solution. Now let's check the points that are on the lines. Look at F. It's on a dotted line. Dotted lines do not work. E is on a solid line. That does work. Now let's look at the ones in the points. A is on a solid. Check. B, solid dashed. Nope. They both have to be solid in order for it to work. Last but not least, looks like C is cut off right there. It's dash solid. No. All right, guys, that just summarizes the review. Hopefully it's helpful.